We start this problem by drawing ourselves a couple of free body diagrams. We have to draw free body diagrams for each of the objects that are in the system. So let's start by drawing a free body diagram on the block which is resting on the horizontal surface. There are three forces acting on the block. There's the force of gravity acting downwards, that's m1g, and then there's the normal force N, that's a normal reaction force, which is applied to the block by the horizontal surface on which it's resting. And the third force is the tension in the string. Now consider the hanging mass M2. Again, ask yourself what forces are acting on that mass. Well, there is the force of gravity acting downwards, m2g, and the tension in the string acting upwards, that's T. Notice we're going to choose our coordinate system so that the x direction is the horizontal direction and the y direction is the vertical direction. Right, let's consider block 1, M1 first. The block will accelerate in the x direction only, and so therefore a1y is equal to 0. Now we're going to write the equations of motion. In the vertical direction, we have that n minus m1g is equal to 0. N minus m1g is the resultant force on our block in the vertical direction. And because the acceleration in that direction is 0, we equate that to 0, and that is also equal to m1a1y. In the x direction or horizontal direction, the resultant force is just T. So putting that into Newton's second law gives us that T is equal to m1a1x. Now I've written both equations of motion, one for the vertical direction and one for the horizontal direction, just for completeness here. But in actual fact, we only really need the latter one, the horizontal equation of motion, T equals m1a1x, as you'll see in due course. Right, let's now consider the hanging mass. We don't need to consider motion in the horizontal direction because there's no acceleration in that direction. So we're just going to write down this time the equation of motion in the vertical direction. And that is m2g minus t is equal to m2a2y. Since the string has a fixed length, it's clear that a2y must be equal to a1x, which we'll just call a. I'm dealing with magnitudes here. So we can represent the acceleration of the system simply as a. From equations 1 and 2, we can say that m2g minus m1a is equal to m2a. That's just obtained by substituting t equals m1a1x into equation 2. Transposing that equation gives us the expression that a is equal to m2g divided by m1 plus m2. And then if we want to determine the tension in the string, we just substitute that value of a, or that expression for a, back into equation 1 for t. So t is equal to m1a, which is equal to m1 m2g divided by m1 plus m2. Right, let's put a few numbers in. If we put in that m1 is equal to 2 kilograms and m2 is equal to 1 kilogram, that will give us an acceleration of 3.27 meters per second and a tension in the string of 6.54 newtons.